radicals are the opposite of exponents. With exponents, you're taking things to a power. With radicals, you're taking their roots. So you're taking the square root or the cube root. And so they'll show up on the test frequently. So we got to master those as well. So let's take a look at some sample practice questions. Start off with the square root of 18 times the square root of 2. You can multiply 18 times 2 to get 36. So that becomes the square root of 36, which is 6. And you move on. Now, what about this next one? The square root of 16 plus the square root of 9. You cannot add the 16 and the 9. It says plus, but you cannot add those together and take the square root of 25, because take a look. If you take the square root of 16, that's 4. If you take the square root of 9, that's 3. 4 plus 3 is 7, not 5, which what you would have gotten if you would have added 16 and 9. So don't add them. What about the square root of 9 divided by the square root of 4? Easy way to do that is to put the square root of 9 in the numerator, the square root of 4 in the denominator. Take the square root of 9, you'll get 3 over the square root of 4, which is 2. The answer is 3/2. Here's another one that's very similar. It's the square root of 64 over the square root of 16. One way to do it is like we did the previous one. We can do the square root of 64 is 8. The square root of 16 is 4. 4 into 8 goes 2 times. However, there's a little trick you can do here. Because 16 is a factor of 64, you can divide it in before you start taking square roots. So 16 into 64 gives us 4. So the square root of 4 is also 2. So you get the same answer. And figure out which one of those two methods works for you and use that on test day. Let's look at the next one. The next one's a little bit different. You've got the square root of x over y. So what you have to do here is you have to change it to the square root of x over the square root of y. So that's how you could restate it, pillar 2. But by convention, you never leave a radical sign in the denominator. So if you come up with what you see here, radical x over radical y, you're not going to see that among the answers. What you are going to see is what they've done is they've multiplied radical x over radical y times 1, and in this case, that's radical y over radical y, that's 1. So you see we're going to multiply the numerator and the denominator by radical y. Well, when we do that, in the denominator, we end up with y, because the square root of y times the square root of y is y, and in the numerator, we end up with radical x, y, all under the radical sign. Notice that. Okay, what happens if you get the square root of 98? You will not see the square root of 98 among your answers because there's a perfect square in 98. So we have to factor that out. So 98 is 49 times 2. So now we've got a perfect square under there, so we have to take that out. That's 7 radical 2. How about radical a times radical b? That's pretty simple. You gather those two terms, a and b, under the radical sign. That's the same as radical ab. Now, what about this next one? Take a look at that. It's radical 9b to the 8th power. So, like before, we can factor out the 9. That's pretty easy. So we'll take the square root of 9 and we'll put 3 to the outside of the radical sign. But what's the square root of b to the 8th? Is it b to the 8th power? What is that? No, it's not. The square root of b to the 8th power would be b to the 4th power. You just need to cut it in half and look and see why. Because isn't b to the 4th times b to the 4th going to be b to the 8th? Because we add the powers. So in that case, if you see anything to a power underneath, and you need to take the square root, it's even. What do? You go ahead and cut it in half so it's b to the fourth power. So the answer would be 3b to the fourth. Next one. Sometimes when you're doing math, it's easier to deal with exponents than it is with radical signs. So to write radical x as an exponent, that's x to the 1/2 power. Because remember earlier, when we were doing exponents, the power was up and the root was down. So this is another way of writing it, and you may find that very, very valuable on test day. So always keep that in mind. Now, what about 1 over radical x to the y? How could you rewrite that? Well, you can rewrite it like we just did, 1 over xy quantity to the 1/2. So that's the same thing as before, but now it's a little bit more sophisticated because you've got xy instead of simply x, but it's the same process. And then finally, what about radical x plus 3 equals 5? What would you do to start off with that little equation? This is very common on the test. Well, it's very simple. What I want you to do is square both sides of the equation. So you would remove the radical sign simply by removing it and writing down x plus 3. That's x plus 3 radical squared. But don't forget, you've got to square the other side. So 5 squared is 25. So now you end up with x plus 3 equals 25. So if you subtract 3 from the other side of the equation, the answer is x equals 22. So that's a little simple review. And now let's move on and do some practice questions. Now let's take a look at question number 1. It says compare the radical 9 and the solution for the equation x squared equals 9. But your immediate reaction is say, well, they look equal to me because the radical 9 is really 3, and this x squared, if I take the square root of both sides, you get x equals 3. Well, that's wrong. And so you can, if that's wrong, you can eliminate A, B, and C. Why is it wrong? I have this question here not because that question itself would show up on the test. It's to remind you something very, very important. Radical 9 is only the positive root. Whenever you see a radical sign, you don't need to worry about the fact that minus 3 times minus 3 is 9. By convention, all the math people got together and said, okay, if it says radical 9, we're just going to worry about the positive root. So radical 9 is positive 3. But if it's in an equation, x squared equals 9, you've got to remember to take the positive and the negative root. So x equals plus or minus 3. And that's answer D. 9, the square root of 9 is 3, which is positive. It can be greater than the solution to the equation because one of the solutions to the equation is x could be minus 3. So that's a little trick I pulled on you to remind you of that very important concept. So now let's go on and take a look at a question that you're more apt to see on the ACT or the SAT. And that is x to the minus 3 equals radical x plus 27. That's question number 2 in your student manual. So I gave you a little preview of that a moment ago to clear that radical so that you can do this solution to this equation. You have to square both sides. So if you square x minus 3, you get x squared minus 6x plus 9. You remember how to FOIL. Then you just remove the radical sign from the right side of the equation and you get x plus 27. Now, you combine the like terms. So we've got an x on the right side, which we have to move over and subtract from the left side. So that leaves us with minus 7x. And then we've got a plus 27, which when we put it over here and subtract 27 from 9, we get minus 18. So now we have x squared minus 7x minus 18. When you factor that, you get x plus 2 at x equals minus 9. So the solutions to the equation are x can be minus 2 and plus 9. You might have forgotten that if one of the solutions is x plus 2, you set that equal to 0, and x becomes minus 2. So that's answer C. So don't panic. If you see a radical sign in an equation, just remember to square it and square everything else that's in the equation as well.